Okay, next we're going to look at other means of evolution. So other means of evolution, we're going to go beyond Darwin's natural selection, and we're going to go past possible mutations, and we're going to look at something called gene flow and genetic drift and non-random mating, which is also referred to as sexual selection. So we'll start with gene flow. Gene flow is the movement of allele frequency due to the movement of alleles into or out of your population. So we're talking about migration. If you think back to when we talked about gene pool and we looked at that picture of the frogs that were green and then some of them were brown, and the allele frequencies, there were a few more green than brown. But what if we had some brown frogs just kind of pop into this population and they're like, hey, this looks like a good place, I think I'll settle here? Then that immigration, them coming into that population, is going to change the frequencies. It's going to change the percentage of green versus brown to now there might be more brown than green. So it's going to change the look of that population. The example from your book focuses on the Great Migration of Marbles. So our population is represented by some blue and white and red and green marbles. And then with the gene flow, we've got some red marbles that are emigrating, they're exiting, they're out of there. So now our population has fewer red. And then we've got some green marbles. They're coming in to the population, so they're immigrating. So now our population has more green and less orange. This scenario looks very possible that you've got a population of beetles and they're green, and then over here's a population of other beetles and they're brown, and this guy, I don't know, maybe he's offended and he leaves to join this bunch. So now this population is going to look different because it has green and brown, and then once they interbreed, that's going to change what the next generation of beetles are going to look like in this population. Okay, next we have genetic drift. And in genetic drift, allele frequencies are going to change by chance. And this comes from either the results of a bottleneck event or from a founder effect, or what's called the founder effect. And this may lead a population to have less variation, which is not good and will lead to less success. All right. Now, I've got a little video clip for you to look at on your own about genetic drift, bottleneck effect, and the founder effect. But I will say that if you're using some type of earphone with this one, you might want to be careful because parts of it get really loud. Okay, now to a bottleneck event. It's some type of catastrophic event. It could be one of those 1,000-year floods, or just a flood, a hurricane, a tornado, a volcanic eruption, or in this case, you've got a bunch of bugs here and somebody just takes out a fly swatter and annihilates a bunch of them. So whatever the event is, you're going to be left with a smaller surviving population. So back to our marbles. After our catastrophic event, we're only left with some red and blue marbles. So all the white and the green, they've been demolished. So that definitely has changed our population, and it's just by chance. Now the other is a founder effect, and I've got a little clip here for you to look at for the founder effect, if you will. And this is just about colonization. So you have like these butterflies here, and for some reason this orange and a couple of these red ones just decide to take off, and now this new area has some butterflies. So this population, because of these pioneers that have moved over here to this new little island, looks very different from this population because, well, none of the white ones decided to go with them. These guys just went on their own, so the population looks pretty different. And then I put this here just so you could look at the differences between gene flow and genetic drift, because they sound a whole lot alike. So gene flow, wherever you go, your genes go with you, is less likely to occur when populations are isolated. So if you have an isolated population of beetles, then you can't have another population of beetles having individuals kind of bleed into your population. It's not going to happen. The movement of genes across landscape. So those genes are going to go with those organisms that move into the new population. And gene flow is going to increase the genetic diversity of the populations. And over time, those populations could start to look pretty similar. Genetic drift is more likely when populations are small and they're isolated. And this change is going to decrease genetic diversity in the populations, and then the populations may become different. So this could be a situation that could lead to speciation, or the creation of a new species. Okay, next to the non-random mating or the sexual selection, basically it's the female's choice, and the females choose her mate. And a couple things that could happen to cause her to choose her mate. It could be a competition thing between the males, or it could be just female choice. Now again, I've got some links here for you to look at. But one of the classic examples, if you're talking about sexual selection, and you're talking about basically this, it's kind of a competition between the males, but it's also trying to attract the female to a particular male. So it's not just about choosing him or choosing him. It's also kind of a competition between those two. And then I've got a little video clip, shake a tail feather, so you can go and look at the peacocks and their display of feathers. So when you're talking about these guys are peacocks, and I'm sure you've all seen the Orbits commercial. I love it. And then she is called a peahen. Now our frogs, they can attract a mate with their calls. So I also have a little clip so you can go listen to some frog calls. Now when it comes to the competition itself, there's intrasexual selection. I'll get it right. And this is competition among the males. So we see them there. These foxes and these kangaroos. It's kind of like, stop hitting yourself, stop hitting yourself. And then who knows what these guys are saying. Looks like that one's had a little chomp on him. Oh, he's the loser. Intersexual selection, the males are going to display the traits for their females. So we can see this guy here is kind of displaying his feathers, and I've got a little video for you to look at for that. This guy's puffing up his red chest. Oh, it's just so beautiful. And then this guy, okay, this is actually a bird, and he's displaying his feathers for this female, and I don't know, she does not look very impressed.